Okay. This section is on inverses, contrapositives, and indirect reasoning. There's kind of a lot in here. You have already done conditionals, if-then statements, and you've already learned about the converse, which is when you switch the hypothesis and the conclusion. So we're going to introduce some new vocabulary here and talk about the inverse and the contrapositive, which are some other ways of writing conditionals. So a negation is just the opposite of the statement. Symbolically, that's going to be, it's kind of like the squiggle and a P. That means not P, or the opposite of whatever your statement is. So for example, if your statement is angle ABC is obtuse, the negation of that statement is angle ABC is not obtuse. Pretty easy to understand. For the inverse of a statement, you're going to keep the hypothesis and the conclusion in the exact same spot. You're just going to say the opposite of them. That's why we had to define negation before we defined inverse. So symbolically, that's going to look like not P, then not Q. Okay, so again, the original condition was P, then Q. The inverse is going to say opposite of P, then opposite of Q. So I have an example here. If I teach middle school, then I work at Patton. The inverse of that would be if I don't teach at the middle school, then I don't work at Patton. You'll see I did not change. The hypothesis is still in the beginning. I just negated that statement, and I negated the conclusion as well. Then we have the contrapositive, and the contrapositive is kind of the last option of the different ways to move around a conditional. This does kind of both the inverse and the converse. It switches the hypothesis and the conclusion, and then it negates both of them. So the switching is like the converse, the negation is kind of like an inverse. So it's symbolically not Q, then not P. And you can see the example here. If you like chocolate, then you like Hershey bars. The contrapositive would be if you don't like Hershey bars, then you don't like chocolate. Okay, so notice the you like chocolate has moved to after the then, and I negated that. I said the opposite of that. You like Hershey bars, this piece right here, has moved to the hypothesis position, and I negated that. So the contrapositive is a switch and a negation. All right, so I have two examples here. For write the negation of ABCD is not a convex polygon, and then number 2, write the converse, inverse, and contrapositive for the following statement. So what I'd like you to do right now is push pause. I'd like you to answer these in your notebook and then come back and check your answer. So please push pause now. Okay, here you can see the answers to that. In ABCD is not a convex polygon. When you're writing the negation, you're not going to say ABCD is not a convex polygon. That doesn't make any sense. So you're going to say ABCD is a convex polygon. In the converse, you can see I didn't negate anything. I just switched the hypothesis, which would be this part here. Let's see if I can get this to work. So this was the conclusion of the original statement. In the converse, that moves to the hypothesis position. Okay. In the inverse, the conclusion stays in its right position, but we negate it. And in the contrapositive, the conclusion, again, this yellow statement, moves back up to the hypothesis position, and we negate it. So that's the contrapositive. All right. Indirect proof is one more piece. Indirect reasoning, all possibilities are considered, and then all but one are proven false. Indirect proof is involving indirect reasoning. If we want you to do indirect proof, we will tell you, write the first statement, kind of like we're going to do here. Usually only the statement and its negation are the only possibilities. It's used in math where there's really only it can be true or it can't be true. There's not like 4 other options of what could happen. The first step is always going to be assume temporarily the opposite of what you're trying to prove. Okay, so it's just the first sentence is always going to be kind of the negation of what you're trying to prove. Okay, so in number 1 and number 2, I'm only asking you to write the first step. So really you're just writing the negation of this proved statement. So I'd like you to push pause now, write that down, and then come back and check your answer. Okay, you'll see here that I have your answers. assume temporarily that a triangle can contain two right angles. Assume temporarily that triangle ABC can contain two obtuse angles. So you're making a temporary assumption, and then what you would do is reason through it to prove that this is the only way it can happen. It's kind of proving the opposite, just really there's no way that can happen, so therefore this original statement must be true. And what I did on the next slide is I took this first one and just kind of worked through an indirect proof for you so you could see what that looks like. In red, you'll see that first statement. That's how indirect proofs start, that assume temporarily the opposite, okay? In green is my reasoning, and I'm working through my reasoning and proving it wherever I can with theorems and definitions and postulates. So the red, assume temporarily that a triangle can contain two right angles. That's always your first one. The green is kind of the next step. If this is true, then two angles of the triangle would both equal 90 degrees by the definition of a right angle. This means that the sum of the angles of the triangle would be greater than 180, since the sum of only two of the angles is already 180 degrees. The figure could not be a triangle if the sum of the angles is not 180 degrees. So I kind of, in green, used reasoning and led you down the logical path to realize why this can't happen. In purple, now I'm going to show where it contradicts the given, which is that I had a triangle. This contradicts the given that the figure is a triangle. It can't be a triangle if the sum of the angles is over 180 degrees. And then your final statement is always just basically restating what you were trying to prove. Therefore, a triangle cannot contain two right angles. It's that final statement. Okay, so that is a little bit with indirect reasoning and inverse, converse, and contrapositive.